I'm going to show how you might use the payment function for a mortgage to compare the difference between paying your mortgage off over, say, 30 years versus 15 years. So I'm just going to put here a label that says amount borrowed. And we'll just do this example for, say, $100,000, but we'll be able to change that if we want, and our formulas should update. And I want to do this comparison for the 30-year and 15-year mortgage at different interest rates. So I'm going to start at the low end, say at 4.5%, and then I want to see what happens at higher interest rates, how that's going to impact my payment. So I have, I'm going to calculate my monthly payment. And here I'm just going to refer to the starting interest, which is our 4.5%, and then I would like to go up 1% here. Oop, not 10%, 0.01. And then I'm going to copy this down the column so I can see how a higher interest rate, say between 4.5 and 10.5, will impact my payment. And so I'm going to compare a 30-year mortgage. Oh, I'm going to insert a row. I forgot a label. So here I want to put interest. So now I'm going to compare a 30-year mortgage to a 15-year mortgage, which are the common lengths of mortgages. And then I want to know what's the difference in my payment at the different interest rates. So here I would like to be able to copy this formula over to 15 years and or rather I'd like to be able to update this pretty easily by copying it over to the 15-year column. So I'm going to say payment here, and I know that I need my interest rate first. So I'm going to select this column. I am going to use mixed cell addressing. So I'm going to do my F4 function, and what I want is that column to stay absolute so that when I copy this over for the 15-year mortgage, I won't have to change that. I need to divide by 12 because I'm going to make monthly payments on my mortgage, and that's the annual interest rate. And then I'm going to put here, I'm going to be paying this off over 30 years. 12 months per year, so 30 times 12 there. And then I need to refer to the amount that I'm financing, and again this needs to be negative because it's from the bank's perspective, and I'm going to use absolute addressing. So again, when I copy it down the column and also over to the 15-year mortgage, it'll update pretty easily. So I want to use absolute cell addressing here. All right, and I hit enter, and I see that a 30-year mortgage at 4.5% is $569. I'm going to copy this down the column, and I see that it really makes a big difference, the interest rate there. I'd like to be able to copy this for the 15-year, or actually I'll just copy this first one because I need to modify it. Now this is referring back to the column A, so that's great. I don't have to change that. So the only thing I have to change in this is the 15 rather than 30 because we're paying it off over 15 years. And we see that our payment's going to be higher, but of course we'll have our house paid off in 15 years rather than 30. So I'd like to know, well, what's the difference in my payment here? How much more am I paying per month? And that would be the 15-year mortgage payment minus the 30-year mortgage payment. And I see at different interest rates how much more I'll be paying per month for my mortgage. And I see that it makes a bigger difference when the interest rate is lower than when it's higher. So that's an example showing how you can use the payment function to calculate a mortgage. Again, if we decide we want to spend $200,000 for our house, we can just easily update that. If the starting interest rate is lower, if we wanted to start, for example, at 3%, our spreadsheet, because we've isolated our assumptions up here at the top, is pretty easy to update. So we'll do a more complicated example in the next video to compare how much interest we're paying if we pay the loan off in 30 years versus 15.